I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on ideal gas equation. Before us, a typical chemistry A-level question on ideal gas equation. A fluorescent light tube has an internal volume of 400 cm cube and an internal pressure of 200 kilopascal. It is filled with 0.03 moles of an ideal gas. What is the temperature of the gas inside the fluorescent light tube? So the first thing to do is to apply the ideal gas equation, which is PV is equal to nRT. Now, you are asked what is the temperature of the gas inside the fluorescent tube. So we'll make T the subject of the formula. Temperature now will be equal to what? PV divided by what? nR. P is the pressure, V is the volume, N is the number of moles, R is the gas constant. So I'm to apply my formula. Temperature T now will be equal to the pressure. The pressure is in kilopascal, so you have to convert it to pascal, which is the standard unit. So between 200,000 multiplied by the volume. The volume is in cm cube, so you have to convert it to meter cube. So you divide by what? 1 million. So it will be 400 times what? 10 raised to the power minus 6. Then divided by the number of moles, which is 0.03, multiplied by the gas constant, which is 8.31. So to get the temperature, so I'm to use my calculator. So you have 200,000 times 400 times 10 raised to the power minus 6 is equal to 80 divided by 0.03 times 8.31. So you have 0.2493, which will now be equal to 80 divided by 0.2493 is equal to 320.89, which is approximately what? Temperature now be equal to 321 Kelvin, which is in standard form, it will be what? 3.21 times 10 raised to the power 2. So the correct answer to this question is what? B. B is the correct answer. So as you can see, it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on ideal gas equation. Before us, a typical chemistry A-level question on ideal gas equation. In this question, you should assume methane behaves as an ideal gas. The gas laws can be summarized in the ideal gas equation below. PV is equal to nRT. The volume of a sample of methane is measured at a temperature of 60 degrees Celsius and a pressure of 103 kilopascal. The volume measured is 5.37 times 10 raised to the power minus 3 meter cube. What is the mass of the sample of methane given to two significant figures? So the first thing is to do is to apply the ideal gas equation, which is PV. PV is equal to nRT. I will know that N is the number of moles, which is equal to mass divided by the molar mass. So that means the ideal gas equation will be PV is equal to, if you substitute N in the ideal gas equation, we'll have M over MR, then RT. So for us we are asked to calculate the mass. What is the mass of the sample? So we have to make the mass the subject of the formula. The mass now, M now, will be equal to pressure times volume times the molar mass divided by what? The gas constant times temperature. So the mass now will be equal to, our pressure is in kilopascal, so we'll convert it to pascal, we'll multiply by 1000 to convert it to pascal, which is the standard unit, which is 103,000, multiplied by the volume, which is 0.00537, multiplied by the molar mass. The molar mass of the gas is 16. The gas is methane CH4. Carbon is 12 plus 4 bracket 1, which is equal to 16, divided by the gas constant, which is 8.31. multiplied by the temperature, we'll convert it to Kelvin because in degrees Celsius, so 60 plus 273, you have 333. So multiply by 333, which is 333. So I'm to use my calculator. So I now have 103,000 multiplied by 0.00537 multiplied by 16. So you have, I think I have to erase this so that I'll have enough space. So I have to erase this so that I'll have enough space. So the mass now you have 8,849.76 divided by, so 8.31 multiplied by 333. So you have 2767.23. So the mass now will be equal to, so I have to use this 849.76 divided by 2767.23. So you have 3.198, which is approximately what? 3.2 gram. So the correct answer to this question is what? C, which is 3.2 grams. So the mass of the sample of methane given to two significant figures is 3.2 grams. So it's as simple as what? ABC. Attempt as many questions as possible. Feel free to reach out to me if you encounter any challenge, any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you for listening. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on ideal gas equation. Before us, a typical chemistry A-level question on ideal gas equation. The gas laws can be summarized in the ideal gas equation. PV is equal to nRT. 0.960 gram of oxygen is contained in a vessel of volume 7.00 times 10 to the minus 3 meter cube at a temperature of 30 degrees Celsius. Assume that the gas behaves as an ideal gas. What is the pressure in the vessel? So the first thing we need to do is to apply, the ideal gas equation, which is PV, PV is equal to what? nRT. So we are asked to calculate the pressure. So we'll make the pressure the subject of the formula. P will be equal to what? nRT over V. Very good. So we have to calculate what is the pressure in the vessel. So we want to calculate the pressure in the vessel. So we'll make P the subject of the formula. We are given the mass of the oxygen gas. We are given the volume. We are given the temperature. So we are going to convert the temperature to Kelvin, which is 30 plus 273. Let's convert it to Kelvin. 30 plus 273, which is equal to 303 Kelvin, 03 Kelvin. Then we're given the mass of the gas. So we have to calculate the number of mole of the gas. Number of moles is equal to what? Mass over the molar mass. The mass is 0.960 and the molar mass is 32, which will now be equal to 0.960, 0.960, I'm using my calculator, divided by 32, you have 0.03. So to calculate the pressure, P will be equal to what? The number of moles is 0.03, multiplied by the gas constant R, which is 8.31, multiplied by temperature, which is 303 Kelvin, divided by the volume, which is 0.007. or which is 7 times 10 raised to the power minus 3. So I'm to use my calculator. So 0.03 times 8.31 times 303 is equal to, divided by 0.007. So you have 1 0 10 10791.1. So the unit is in Pascal, so we have to convert it to kilopascal, divide by 1000 to convert it to kilopascal. So you have 10.79, which is approximately what, 10.8 kilopascal. So the correct answer to this question is what, C. C is the answer, which is 10.8 kilopascal. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. Thank you for listening. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on ideal gas equation. Before us, a typical chemistry A-level question on ideal gas equation. What is the density of a sample of fluorine gas at 32 degrees Celsius and 100,000 Pascal? Assume fluorine behaves as an ideal gas under these conditions. So we have to calculate the density of a sample of fluorine gas. So the first thing to do is to put down the ideal gas equation, which is PV. PV is equal to nRT. P is the pressure in Pascal. V is the volume of the gas in meter cube. N is the number of moles in moles, R is the gas constant, and T is the temperature in Kelvin. And remember, N, which is the number of moles, is equal to the mass over the molar mass of the gas. So if we are to substitute this into the ideal gas equation, where we have N, we put mass over molar mass. Then we have PV is equal to what? Mass over molar mass of the gas, then RT. Now the next thing to do is we are going to want to calculate the density of the gas, and we know that density is equal to what? Mass divided by the volume. So the first thing we are going to do, we are going to derive the formula to calculate the density of the gas from the ideal gas equation. So we have to cross multiply. When we cross multiply here, we now have PVMR is equal to what? MRT. Now, the next thing to do, we already know that density is equal to what? Mass over volume. So we want to make PMR the subject now. So we divide both sides by V, divide here by V. So when you cancel out, you have PMR is equal to mass over volume, which is density. So we have to substitute density, which is mass over volume, into this equation. So it will now be what? Mass over volume is density. So it will now be density times gas constant times the temperature. So we've gotten the equation. We've gotten density into the what? Into the ideal gas equation. So the next thing to do is to make density the subject of the formula. So to make density the subject of the formula, you divide both sides by what? RT. So density of the gas now will be equal to what? Pressure of the gas times relative molecular mass of the gas divided by what? The gas constant times the temperature. So this is the formula we're going to use to calculate the density of the gas. So I have to erase all this so that I have enough space. So I have to erase this. So the density of the gas D is equal to the pressure. The pressure is 100,000 Pascal times the molar mass of the gas is fluorine. The relative atomic mass of fluorine is 19. So fluorine now will be equal to relative molecular mass of fluorine, which will now be equal to what? 19 times 2. So the molar mass of fluorine now will be equal to what? 19 times 2 is 38. So times what? 38 divided by the gas constant is 8.31 times the temperature. Temperature is in Kelvin. So we have to convert, temperature has to be in Kelvin. So we'll convert 32 degrees Celsius to Kelvin, which is 32 plus 273. It now be equal to what? 305. So multiply by 305. So the density will now have So I'm to use my calculator. So we'll have 3800,000 divided by 8.31 times 305. 8.31 times 305, 2534.55. So I'm to use my calculator now. So 308,000 divided by 2534.55. So you have what? 1499.27. 1499.27. So since our answer is in gram per DNQ, we have to divide by 1000 to convert it to gram per DNQ, which is the density of the gas. So if you divide by 1000, you have 1.499, which is approximately what? 1.5 gram per DMQ. So the correct answer to this question is B, which is 1.5 gram per what? DMQ. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty, any challenge. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much for listening. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on ideal gas equation. Before us, a typical chemistry A-level question on ideal gas equation. In this question, it should be assumed that nitrogen behaves as an ideal gas under the conditions stated, which volume is occupied by 1.00 gram of nitrogen at 50.0 degrees Celsius and at a pressure of 120 kilopascal. So you have to calculate the volume occupied by 1.00 gram of nitrogen at 50 degrees Celsius and at a pressure of 120 kilopascal. So applying the ideal gas equation, PV. So we have PV is equal to what? nRT. And we all know that number of moles is equal to what? Mass over the molar mass. Now, what is the mass of the gas? Let's calculate the number of moles. The mass of the gas is 1.00 gram divided by the molar mass. Nitrogen is the gas. Nitrogen is 14. So the molar mass now will be equal to what? 2 times 14. That is the relative atomic mass of nitrogen. 2 times 14 will be equal to, nitrogen is diatomic, so 2 times 14 will be equal to 28. So the molar mass of nitrogen is what? 28. So the number of moles now will be equal to, I have to use my calculator, 1.00 divided by 28. So you have 0.0357 moles. That is the number of moles of nitrogen. But we're asked to calculate what? We're asked to calculate the volume of nitrogen. So make the volume the subject of the formula. The volume now will be equal to what? Number of moles times the gas constant times temperature divided by the pressure. So we'll have the number of moles, which is 0.00357 multiplied by the gas constant, which is 8.31, multiplied by temperature. The temperature have to be in Kelvin, so we'll convert 50 degrees Celsius to Kelvin. So we'll have 50 plus 273 to convert it to Kelvin. So 50 plus 273. So we'll have what is equal to 323 Kelvin. So the temperature is 323. Divided by the pressure. Pressure is 120 kilopascal. So we'll have to convert it to pascal. You multiply by 1000. So 120 times 1000 will be equal to what? 120,000 pascal. So divided by 120,000. 120,000. So we want to get the volume of the gas. So I have to erase this so that I will have enough space. So let me erase this so that I will have enough space. So to calculate the volume of the gas, so the volume Volume of the gas now will be equal to, let me use my calculator, 0.0 coming 1 divided by 28. So it's supposed to be 0. I think I have to erase this. The number of moles is 0.0357. Yeah, there is a 0.0357, not 0.00, 0.0357. So I have to correct that. So the volume now will be equal to, so I have to use my calculator, 0.0357 times 8.31 times 323. So you have 95.823441 divided by 120,000 divided by 120,000 will now be equal to what? 0.00 0.0007985. So divide by 1,000. So not divide, you have to multiply by 1,000. So 0.0007985 multiplied by 1,000 will be equal to what? 0.799 dm cube. 0.799 dm cube. So the correct answer to this question is what? B. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.